Hello dear students, welcome to our YouTube channel. This video is all about vectors. We'll start with very basic concept of the physics, which is physical quantities. Then we will discuss about difference between scalar and vector quantities. Very important if you are in 10th grade or GCSE or in AS and A level. And then we will discuss about how to represent vector quantities. Okay, how do we represent vector quantity in different unit. Then finally positive and negative vector. So grab pen and paper and start making your notes. What are physical quantities? Simply those quantities which represent laws of physics and can be measured using instruments. For example, length. We can measure the length by using ruler, vernier calipers and screw gauge. There are lots of instruments we can use to measure the length, and we use length to explain motion. Yeah. So let me write down definition of physical quantity. Now what do I mean by this definition? Simply those quantity which can be measured and explains laws of physics. For example, temperature. Okay, temperature can be measured using thermometers. So we can use thermometer. Thermometer is an instrument. So temperature can be measured using thermometer, and we use temperature to explain very important law of physics, which is law of thermodynamics. So we use temperature to explain thermodynamics. One more example. Okay, example, current. What do we use to measure the current? Ammeter. So we use ammeter to measure the current. So we measure the current using ammeter, and current explains law of electricity. Yes, current electricity. We use current to explain the law of current electricity. So this is the definition of physical quantities. Those quantities which can be measured and explains different laws of physics. These are our physical quantities. We have lots of physical quantities. But how do we represent physical quantities? We need two things to represent physical quantities. Okay, so physical quantity in short form PQ. Let me write down the full name, otherwise you will get confused. Physical quantities. Physical quantities needs two things. One is magnitude. Magnitude, it means numerical value. Numerical value. And we need unit. Remember, all the physical quantities have their specific symbol and their corresponding unit. For example, force. We can write down the force like 5 Newton. So 5 is numerical value or magnitude, and this N is unit. This N is the symbol of Newton. Okay, we write as symbol capital N. One more example, mass. What is the symbol of mass? Small m. Okay, symbol of force is capital F. Okay, symbol of mass is small m, and let's say there is a box and mass of the box is 100 kg. So I can write 100 kilogram. Kg is kilogram. So this 100 is numerical value or magnitude of the physical quantity, and kilogram. Kilogram is the unit. Kg is the symbol of kilogram. Okay. One more example. Time. What is the symbol of time? Small t. Let's say 50 seconds. 50 s. S is the symbol of second. Okay. So 50 is our magnitude and s is unit. So this is how we represent any physical quantity. All the physical quantities are divided into two major categories: scalar quantities and vector quantities. Simply, scalar quantities are those quantities which do not need direction. So I can say scalar quantities don't need direction. Okay. Do not depends on direction. When we talk about any scalar quantity, no need to represent direction. But when we talk about vector quantity, we need direction. To represent any vector quantity, we need direction. Both vector quantities have one thing which is common: magnitude. So both need magnitude. Magnitude means numerical value. Let's say 50, 30, 40. We know any physical quantity needs magnitude. So magnitude is there in scalar quantity as well as vector quantity. So magnitude. So direction is the first major difference between scalar and vector quantity. Let me take one example. Example, mass. Mass is our scalar quantity. Let's say mass of this object is 100 kg. Okay, 100 is our magnitude and kg is unit of mass. Now 100 kg, when I say 100 kg, I don't need direction. I don't say 100 kg towards right or left. 100 kg, it's a complete information. We don't need direction to represent mass of any object. So it's scalar quantity. Then temperature, let's say 30 degrees Celsius. So 30 degrees Celsius, we don't need direction. In which direction we have 30 degrees Celsius temperature? No, just 30 degrees Celsius, it's complete information. So it's scalar quantity, we can represent it without direction. So temperature, what is the symbol of temperature? Capital T. Symbol of mass is small m. Anything else? Distance. Okay, I'll tell you distance and displacement together. Let me take example of vector quantity. For example, force. Force. Symbol of force is capital F. Let's say there is a box and there is a 5 Newton of force on this box. When I say 5 Newton of force on the box, it's incomplete information because we need direction. 5 Newton of force in which direction? Is it towards right, left, upward or downward? So when we represent force, we need direction. For example, for this case, we have 5 Newton of force towards east. So when I write force, I need magnitude and direction. This 5 Newton is our magnitude and east is our direction. Let me take one more example, very popular example, distance and displacement. So let's say this is our home and over here we have school. So there are two paths from home to school. First one is like wavy, it's not the short path, it's a long one, path 1, and path 2 direct, home to school. Okay, this one is our path 2. If you look at path 1 does not have specific direction. Sometime it's upward, sometime it's towards east, sometime it's downward. So no specific direction. So this is our distance. But if we look at path 2, specific direction from home to school towards east. So specific direction towards east. Towards east. So this path 2 which have specific direction from home to school towards east, it's our displacement. Displacement. So we can say distance is our scalar quantity because do not have specific direction, and displacement is vector quantity. Why? Because displacement have specific direction. We have lots of example of scalar and vector quantities. Let's say work, energy, speed. These all quantity do not need any direction. We can represent all these quantities without direction. So comes under scalar quantities, vector quantities, velocity, acceleration, electric field. Do you know what is the direction of electric field? It's always from positive to negative. So positive charge, positive to negative, or we can say away from positive and towards negative. So that's the direction of electric field. Then magnetic field. These all are example of vector quantity. Okay, so far we understood what are physical quantities, how do we represent physical quantities, and difference between scalar and vector quantities. We can represent any vector quantity by simple arrow. Something like this. This part of the arrow we call it tail region, tail, and this part is head. Now what is the significance of tail and head? So tail part shows you magnitude of any vector quantity. So magnitude, and head part shows you direction of any vector quantity. Direction. Which direction? For example, 5 Newton of force towards east. So this 5 Newtons represent by the length of the arrow, and this head region shows you the direction which is towards east. Okay, one more example. 8 Newton of force towards north. So the length of the arrow shows you the magnitude. We can see the length of this arrow and this arrow is different because magnitude is different. As we increase the magnitude, length will be increased, and this head region shows you the direction of the vector quantity which is towards north. So this is how we represent any vector quantity, and we represent vector quantity as a formula. F is equal to magnitude of F into direction. So when we write 5 Newton towards east, so this 5 Newton is the mode F, and towards east is your direction. What do I mean by positive and negative of any vector? For example, there is a vector A towards east, vector A. Let's say this vector A is our displacement 8 meter towards east. In order to write negative of vector A, we have to take opposite direction, exactly opposite direction with same magnitude. So 8 meter towards west is our negative of vector A. So this will be your negative of vector A, having same magnitude 8 meter but opposite direction. It means I turned this positive vector by 180 degree. So remember, angle between positive and negative vector is always 180 degree. Let me take one more example. Vector B. We have vector B over here. Then what will be the negative of vector B? This will be your negative vector B. Same magnitude. Let's say this one is 5 meter. Then this will also 5 meter. And the angle between positive and negative vector B will be 180 degree. For example, vector C over here, negative of vector C will be opposite, exactly opposite direction with the same magnitude. So this will be your negative vector C. So this is how we represent positive and negative of any vector. But what is the importance of positive and negative vector? We use positive and negative vector for the addition of vector and subtraction of vector. So next video is all about addition of the vectors.